Okay, so here's an example of one of the final questions that we're going to have on our unit test coming up. So it's an optimization question, and we want to know stuff about the height of a rocket in this case. So the height of a rocket after it's shot upwards is given by the equation h of t is equal to negative 5t squared plus 30t plus 35. So h of t is height in meters, and t is time in seconds. So what we want to know from this is a few things. How long does it take for the rocket to reach its maximum height? We want to find the maximum height of the rocket. How long does it take for the rocket to hit the ground after we fire it? And what is the height at t equals 0? So we're going to go through this step by step here. So the first one we wanted to know is how long does it take for the rocket to reach its maximum height? So automatically you should look right here on your A term and notice that we have a negative value. So when we have a negative value on the term that's squared, or A term in the quadratic, we're going to have a parabola that looks like this, right? So the negative means we have a sad face here. So in order for us to know what its max height is, we need to know what the line of our vertex is, or our axis of symmetry. And that is given to us by x is equal to negative b over 2a. So let's take our terms here. So we'll find out what our axis of symmetry is. We'll have negative 30 over 2 times a negative 5. So that works out to be negative 30 over negative 10. And x in this case is 3 seconds. So it took 3 seconds for our rocket to reach its maximum height. So anything that's asking you for the max or the min using this, and we want to find our vertex through finding our axis of symmetry. So moving on to the next one. If we knew that we had the time at which it was the maximum height, then we can find out what the maximum height is. So we'll have 3 seconds was t from when it was the maximum height. And we'll just plug that into our equation. So h of t in meters is going to be negative 5 times 3 squared plus 30 times 3 plus 35. So we're taking where our vertex is on our x-axis and we're applying it to the height function. So we're going to see how tall our rocket hit. So negative 5 times 9 plus 90 plus 35 is going to give us negative 45 plus 90 plus 35, and that all works out to be 80 meters. So at h of 3, our rocket hits 80 meters. So we know that that's our final answer for the maximum height of the rocket. So we know when the rocket hit its maximum height, we know how tall it was or how high it hit when it went for its maximum height. Now we want to know how long does it take for the rocket to hit the ground. So when you're looking at this, you'll realize hit the ground, that's when it's at h of t is equal to 0. So we're looking for the roots of our quadratic. So in this case here, we're looking where h of t is equal to 0. So here we'll set our equation equal to 0. Minus 5t squared plus 30t plus 35. And we'll solve this just like a regular quadratic. So we'll probably have to split for this method here, and we'll see so what two numbers need to multiply together to get negative 175 and add together to get 30. And in this case here, it'll be 35 and a negative 5. So 0 equals negative 5t squared. And we're splitting right here in case just if you wanted to follow along. We'll go plus 35t minus 5t plus 35. So we can factor out a negative 5t. We'll be left with t minus 7. We'll factor out a negative 5 here. We'll have t minus 7 again. All of that's equal to 0. And we'll have 0 equal to negative 5t minus 5 in brackets and t minus 7. So when we set these equal to 0 again, we'll have minus 5t equal to 5, t is equal to a -1. We can't have a negative number here because it's in respect to time, so we're going to cancel this out and not use this. The other one we'll have is t minus 7 equals 0, t equals 7. And in this case, this is great, right? Because it's a positive number, and after 7 seconds, that means that our rocket will be hitting the ground. So we know that after 7 seconds after firing it, using this function, it should be hitting the ground. Finally, what is the height at t equals 0? Well, this one's one of the easier types of questions you'll see, where you just need to plug in 0 for t. So we'll go back to our equation. We'll say h of 0 is equal to -5 times 0 squared plus 30 times 0 plus 35. And this is essentially finding the y-intercept. So we know that there's nothing coming out of this or that here. So h of 0 is equal to 35. And that's how high the rocket was shot from. So that's the ledge or the prop where the actual rocket was shot. Okay, so let's piece all of this together, all the parts of the question. So we see we have on our y-axis, or our h of t axis, so that's the height, and down here we have t in seconds. So let's graph this out. The last little bit we just found out was that we had a y-intercept at 35 meters. So that's where our rocket was shot from. We also knew that we had a point or a vertex lied at t equals 3, so t equals 3 here. And we know that our vertex was also at an y-axis, or a y value of 80 meters. So we know that what we're going to see is right at 3 seconds we're going to have our max, right? So the very highest that our function hit. So coming from 35 meters we will touch right here at our vertex, and then our equation will come down, or our function will come down and hit at t equals 7 seconds. And that's where the root was, or where h of t is going to equal 0. So when it touches the ground again. That wasn't the best looking graph, but you get the picture. One of the other roots that we saw was at t equals -1. Now if this were to continue over into the negatives, that would fit, but again we're only dealing with positive values because this is dealing with time and we can't have negative time. So right here we had a vertex of 3 and 80, and that was our maximum. Right? So that is the very highest point that our rocket hit. And a lot of these questions are either going to be asking for maximums or for minimums. So for a minimum, what we would have something that would look like similar to our x-axis and our y-axis here, but our minimum would be down and through, and we'd be asking the question, at what x value do we reach our minimum here? So that's our minimum for the vertex there. So again, our vertex usually is in h and k. So for right now with this question, this is what we had to work with. Try the questions that I assigned from the textbook and begin reviewing for your test next week. Thanks for watching.